Hey guys, Jay Spark from Triumph Tutoring here, just going through our fractions worksheet. So I'm going to lay out some solutions for you today. We're going to start from the top and work our way down. So first up, I'm adding two fractions together. Now when we're adding fractions or subtracting fractions, it is important that our denominator is the same. As you can see for these first two questions, the denominator is the same in both of them, which is going to make our job nice and easy, because all I have to do is add the tops or subtract the tops, or the numerators. A good way to visualize this is, well, this 2 over 6, we can imagine that we have a box of pizza, and that pizza has 6 slices in it. Now this particular box has 2 of the 6 left in it, while another box may have 3 of 6. And for safekeeping, and to have our pizza for breakfast tomorrow morning, we put those 2 slices with those 3 slices in a box of 6, which means that we end up with 2 plus 3, 5 in a box of 6. The same could be said over here, in this example, 5 over 6 minus 3 over 6. We have a box of 6 pieces of pizza, there's 5 of them left, and our good mate Tom comes along, subtract 3 of 6, he eats 3 of our 5 pieces of pizza in a box of 6, and we end up with 2 out of 6 left. Now multiplying fractions is actually super easy. So what we do when we're multiplying fractions is literally multiply the 2 tops numbers, multiply the 2 bottom numbers, and that's going to give us our fraction. So 3 times 2 is 6, and 4 times 3 is 12. So we have 6 over 12, which we can simplify down to 1 over 2. Over here, 3 over 2 divided by 1 over 4. Now dividing fractions may seem scary, but it's actually quite straightforward. It's only one step more complicated than timesing fractions. What we can do is convert this equation into one that has a multiplication sign instead. And how we do that is we flip this second fraction. So this is a little trick for you. If you want to make it nice and easy, 3 over 2 times 4 over 1. So we can, if we flip this second fraction to 4 over 1, that becomes a multiplication symbol. And we end up doing the same as when we multiply fractions. So we times the tops and times the bottoms. So here we end up with 12 over 2. 12 divided by 2, that's a terrible equal sign, there we go, is equal to 6. Let's go down here. Now it's a little hard to see, but this is actually one fraction being divided by another fraction. So the same as what's happening over here, it just looks a little different. So this is 2 over 5 divided by 3 over 4. Same as what's happening over here. So I could rewrite that as 2 over 5 divided by 3 over 4. Which, as we know before, we can turn into a multiplication sign by flipping the second fraction, which means we end up with 2 over 5 times 4 over 3. 2 times 4 is 8 over 5 times 3 is 15. And that's as simple as that fraction gets. Here's where things get a little bit more tricky with adding fractions. In order to add 2 fractions, we need to have the same denominator. And the easiest way to do that is to times each denominator by the other denominator. So this 5 will be times by 7, and this 7 will be times by 5. Now we can't just go timesing whatever we want, otherwise these fractions will end up being different fractions to what they were. So if we just times this bottom 5 by 7, this would end up being 3 over 35. And that's not the same as 3 over 5. So in order to keep them the same, whatever we do to the bottom of the fraction, we have to also do the top. So if we're timesing by 7 on the bottom, we also times by the top. Same goes over here. So we have 7 times 5. So we're going to times our 2 by 5. What that's going to give us is 21 over 35 plus 10 over 35. Now when we add our pizza slices together, we've got a box of 35 with 21 in it over here, a box of 35 with 10 of the slices in it over here. 21 plus 10, you get a box with 31 slices out of 35. Cool. Second last question, 5 minus 4 over 3. Now this is weird because we have a whole number over here minusing a fraction, except it's not actually too hard. if we convert this whole number into a fraction, it's going to make this a lot easier. We're going to do the same things we do over here. We make our denominators the same, and then we can minus the numbers from each other. 5 is a whole number, but as a fraction, we can also rewrite that as 5 over 1. So 5 over 1 minus 4 over 3. This is looking a little more familiar to us and a little easier to work with. So same as before, in order to add or subtract fractions, I need the same denominator. How do I do that? I times the denominators by each other and make sure that the fraction also stays the same. So I have 5 times 3 over 1 times 3 minus 3 times 1 and 4 times 1, which 5 times 3 is 15 over 3 minus, and 4 times 1 is 4 over 3. 15 over 3 minus 4 over 3 equals 11 over 3. Last question. So I have 3, once again a whole number, timesing by a fraction. The same as we did over here, we're going to convert our whole number into a fraction itself. So 3 as a fraction is the same as 3 over 1. Times by 2 over 7. Now this actually looks pretty straightforward from here. I'm going to times the tops and times the bottoms to get my answer. 3 times 2 is 6. 1 times 7 is 7. And there you have it. That's our fractions sheet.